Hi there everyone, today we're going to look at accuracy with bounds. Alright, so if you're working with upper and lower bounds, sometimes they ask you in exam questions about leaving your answer to a suitable degree of accuracy. Now if you're not quite sure what that means, then you might just round incorrectly. Alright, so we're going to show you what that means. So if you're working, like I said, with bounds, so you need to basically work out what your solutions are in both worst and best case scenario. Alright, obviously depend on the question. And then from there, round to one that fits both those two potential solutions. All right, so I'll give you an example in terms of what that means. So if I said you've got a equals 2 and b equals 183 to the nearest integer, all right, and if I actually said, right, y is equal to the square root of a plus b, and then find the value of y to a suitable degree of accuracy, all right. So what you've got to do is you've got to work out, well, what are the two options that I could have using a and b that's going to give me the smallest value? What are the two values that I'm going to have to use a and b that are going to give me the highest value, and then round both those two numbers so that I get the same thing. Okay, so let's do it. So in terms of upper and lower bound, well, let's go for basically lower first. It makes sense. Well, the lower bound for 2 is 1.5. That's the lowest it could be. And then for b is 182.5. Again, that's the lowest it could be. So add those two and square root it, and you've got 13.564. Okay, so that's your lower bound. That's your basically lowest solution based on the information you've got. And again, if you're not quite sure what I'm talking about in terms of upper and lower bounds, then please look at the lesson on upper and lower bounds first of all, obviously because this is in relation to that. Okay, so look at that one first, then come back. Your upper bound, now we're talking the higher limit. All right, and again, because we're talking bounds specifically, obviously we know it can't be 2.5 exactly, but anything less than that. So this is our upper limit. So 2.5 and 183.5, okay, square rooted, would be 13.638. Okay, so I've got two different answers here. And because it wants an answer to a suitable degree of accuracy, now I can't say to two decimal places that they're going to give me the same answer. If I do to one decimal place, well, the 5, this would round up to 13.6, and then this would round to 13.6. So a suitable degree of accuracy, if I round them both to the same level, I can say safely that 13.6 would give me an answer, because anything in between those two values that I've chosen, this would be slightly lower than this would be slightly higher than this, but either way, you're going to get 13.6. All right, so that is rounded to a suitable degree of accuracy using bounds. All right, so that's what we're looking for. Now, it doesn't have to be one decimal place. It could be a variety of different kind of rounding solutions. It could be to the nearest whole number. It could be to 3 decimal places. We don't know until we actually do it. So you have to go through that kind of process of working out the upper and lower bound for the two solutions, and then round them so you end up getting the same thing. Okay. If you need some practice on it, please go to maths-school.co.uk, link at the bottom of the page, and of course there's some questions on there for you to practice on. Thanks for listening.